Okay, our next problem here, we're going to practice reading a story, drawing a graph from it, and then analyzing, is it a function, is it not a function? And then drawing another one below, kind of comparing two different variables. But to begin, it says Taylor is running in a marathon. In the first hour of her run, she maintains a constant speed of 11 minutes per mile. So I'm going to start highlighting things because there's going to be a lot going in this problem. So in the first hour, she maintains a constant speed of 11 minutes per mile. At the 1 mile marker, she stops on the sideline to drink a bottle of water. Let's start using different colors maybe. So at the 1 mile marker, she stops at the sidelines to drink a bottle of water. This break takes 2 minutes. She then continues running the next mile at a constant speed of 15 minutes per mile. I'm making sure I'm highlighting that word constant because just like in the car problem, if I'm going at a constant speed, I know that line is going to be nice and straight. So I want to be very precise when I'm drawing these graphs. A says sketch a graph comparing time on the x-axis to distance on the y-axis. So I'm going to go ahead, I'm going to fill in time. And then we have distance. So I'm going to fill in my numbers and I'm going to think. So her rate is talking about minutes per mile and minutes per mile. So even though it's talking about in the first hour, I'm still just going to talk about minutes. So then I'm going to go ahead and maybe I will count by 2, 4, 6, 8. Come on, pen. 10, 12, 14, 16, 18, 20. Good enough. Alrighty, so then I'm talking about running miles. So I'm gonna count by, I'm still counting by ones here. Notice I'm skipping lines just to make it a little bit less cluttered. All right, so now I'm gonna go ahead and think about my graph. So the first thing I'm gonna do is that pink part. So in the first hour, she runs at a constant speed of 11 minutes per mile. This piece right here is going to tell me what my first coordinate is. If I go 11 minutes per mile, that means for the first mile, I was running for 11 minutes. So I can come down here. I know 11 minutes, and then I'm going to go ahead and draw for 1 mile. Again, try to be as straight as possible. I know if you're using a device, it might be kind of hard. Okay, so that shows my constant speed of 11 minutes per mile. So then it says at the 1 mile marker, she stops, takes a break for 2 minutes. So if she's taking a break, that means that time is still moving on, but my distance is staying the same. Okay, so I'm going to keep my distance marker the same, but I'm going to increase for 2 more minutes. So right now I'm at 11 minutes. So 2 minutes later, I would be over here at 13 minutes. So there's my stopping point. And now I'm going to finish up with my green. So for the, what does it say? She then continues running the next mile at a constant speed of 15 minutes per mile. Okay. So if I'm going 15 minutes per mile for the next mile, so I know that I'm going to have to come up to 2. And I'm not exactly sure. It's not as easy for me to think as it was for my pink line, right? I was starting at 0, so I came right over to 11 minutes for 1 mile. However, I'm changing speeds here. I'm not exactly sure for my 15 minutes maybe for the up one, but I can just think about it. 15 minutes per mile is going to be a little bit slower than my pink, which was 11 minutes per mile. So think about that turtle task again. The steeper you made your line, the faster that turtle was moving. So if I'm moving slower, that means my line is going to be a little bit less, okay? Or if we want to go ahead and count 15 minutes out and then up a mile, we can also do that because for the next 15 minutes, we ran another mile. So if I'm at 13, 13 plus 15 gives me 28. I didn't put that on my x-axis, so I actually don't even have enough space to fit that, which is fine, again, because I'm going to just use the knowledge that if I'm moving slower, then my line is going to be a little bit less steep. It doesn't look that much less steep, but we get the point. Hard to draw because my scale wasn't the best. Okay, so there's my graph. She's running 11 minutes per mile, stops, and then 15 minutes per mile. And I'm showing here that I'm going a little bit slower than in the pink because my line is a little bit less steep. A little bit hard to see here. Again, I didn't pick the best scale here. The better you pick your scale, the easier it's going to be to see. But again, we see the point here. Question B says, is the graph of time versus distance a function? So I'm looking at this. I don't see her being in 2 places at once. So we're going to go ahead and say yes. No y values repeat, meaning Taylor is never in two places at once.